Okay, this is Algebra 1, section 6.2, substitution. We're on page 348. Okay, now you'll remember, if you go back and look at your notes, okay, you'll remember that there were three methods that we use to solve a system of equations. Graphing, elimination, and substitution. Very good, Tyra. And we are now on substitution. Let me talk to you about substitution. Okay, substitution is a wonderful method. What's its only drawback? Well, there's two drawbacks to it. What's one of them? You can't see it. Very good, Caden. You can't see your answer. And so we forget their lines. The second one is it can be very tedious if something is not in the right form. Okay, now let's talk about the form. All right, in substitution, it works great. Works great if two things happen. If one of two things happen. I'm just going to state it like that. The first one is one of the variables is solved for. Did I say y? Did I say the letter y? Can it be x? It can be x or y. Does not matter. Now, most generally, we solve for what? We solve for y, don't we? Okay? We solve for y because we can graph it easily, right? All right. So substitution works great if one of two things happen. Number one is one of the variables is solved for. Number two, one or more. Here's a word, coefficients. And I might have to remind you what that is. One or more coefficients are 1, are the number 1. And substitution works great for this. So Tatum, if I'm doing problems, I'm going to look and see if this is the case. You understand what I'm saying? Okay, now let me give you an example so you know. Jackson, do you have any questions so far? No. Okay. All right, so the directions are going to say use substitution to solve each system. Now remember, a system is two or more lines, right? Now, Caden, we're not going to be able to see our answer, so it could pose a problem with what we're doing. Y equals 2x plus 1 and 3x plus y equals a negative 9. Now, since we're not going to graph it, Mr. Lords, we forget that these are two lines, correct? And two lines can do one of three things. They can intersect, they can be parallel, or they can coincide, correct? All right. Now, taking a look at this, is one of these two things relevant in this question? Tyra says yes. Which one?
The first one.
Yes. One of the variables is solved for. See, y equals 2x plus 1. Do you see that? We have it solved for. Braxton, do you see that?
Yep.
All right, so what we do is, we know that y equals this, so we're going to substitute, we're going to circle what y is equal to. Okay? And then I'm going to draw an arrow where it goes into. And it goes in right there. How do I know it goes in there? In the other equation, because y equals that. So I'm going to substitute it in for the y. So in other words, on the second equation, I'm going to have 3x plus 2x plus 1 equals a negative 9. Notice where the y was, I've replaced it with 2x plus 1. Now, Tirsa, you know if you did it right, if you only have one variable. Now do we only have one variable? Taylor, do you see we only have one variable? All right. So what we get is 5x plus 1 equals a negative 9. Did you notice I added the like terms? And now I just solve for x. So actually I'm going to subtract 1 from both sides, correct?
Mm-hmm.
Which is the same as plus a negative, right? So I have 5x equals a negative 10. And Jackson, now what do I do?
5x
so x equals what? Okay, now a lot of students will leave this as my answer, circle it and say, all right, I'm so awesome, and they'll move on. What's the problem? What's that? You have to find y, don't you? You have two lines that are intersecting, and they intersect at an xy. And we forget this because we forget we're doing two lines. So we take this, and this is why I circled it. I know exactly where to put it in. So I have y equals 2x plus 1. I put the negative 2 in for x, and I get plus 1. And now I can solve for y. 2 times a negative 2 is a negative 4 plus 1, and that is equal to a negative 3. Jackson, did you understand everything I did there? I took the x, put it back into where I circled it in the beginning. Do you understand that? Mm-hmm. And so my answer, where these two lines intersect, is a negative 2, a negative 3. I want to caution you, Braxton, that it must be in the order of x, y. And a lot of students, if you solve for y first, will get it backwards. Do you understand why? Okay. It's easy to do. Is there any questions about this? All right. Let's take a look at a second example. Yeah. Okay.
What if none of them are always solved for y? Or solved for a variable?
That's what we're going to talk about right now. All right. Good question. All right. Let's say we have x plus 2y equals 6. We have 3x minus 4y equals 28. Correct? Write that down. Here is what Braxton is talking about. There are none of them that are solved for y or x, right? So the first one is out. One of the variables is not solved for. All right, that one's out. But what does the second one say, Chuck? One or more coefficients are 1. Coefficients are the numbers in front of the variables, right? So what's the number in front of x?
1.
What's the number in front of y?
2.
What's the number in front of this x?
3.
And this one?
Negative 4.
-4. It's plus a -4, correct? So is one of those, or one or more, 1? Yes, the first one. This guy right here. Right here. So what we do, Braxton, is we solve for him. All right, now I'm going to put it down here. You ready? I'm going to move the 2y over to the other side. So I get x equals, and when I move it to the other side, Braxton, it becomes negative, correct? Mm-hmm. All right, so I have a negative 2y plus 6. Do you understand that, Tater?
Yep.
All right, what about you, Tyra?
Yep.
Chuck?
Yep.
Okay, now, do we have x solved for, Braxton? We have a variable solved for. There's no number right there except for 1, right? So I circle it now. I'm going to do the same exact thing I did. I'm going to put it in for what, though?
Y.
No.
Or x.
I'm going to put it in for x. How do I know which one to put it in for? Because it says x equals that, right? So now, watch this. 3 times x, but I'm going to put all this in. So I have a negative 2y plus 6. Why do I put it in parentheses?
Because you need to distribute.
That's right. You need to distribute. Correct. Excellent. And I'm going to go plus a negative 4y equals 28. Now take a look at that, Caden. Do I just have one variable? I just have y, don't I?
Mm-hmm.
So I am good to go. All right, so now I distribute as Braxton said. So I'm going to bring this here and this here. And I'm going to have a negative 6y plus 18 plus a negative 4y equals 28. I look at like terms. This one and this one are like. So I put them together and I get a negative 10y plus 18 equals 28. Now I'm going to subtract 18 from both sides. And I get a negative 10y equals 10, isn't it? And I divide by negative 10. And I get y equals a negative 1. Now once again, I have a lot of students that circle this answer and are very proud of themselves, slap themselves on the back and move on. However, we have two lines that are touching and they have to be in an XY coordinate. So now I'm going to put that back in and I've conveniently circled where I'm going to put it in. Do you see why I have you circle it? So there's a lot of work here, right? I could get really confused about where to put it in, right? So now I'm going to put it into x equals a negative 2 times a negative 1 plus 6. Does everybody understand how I did that?
No.
Okay, see this right here, Braxton?
Yeah.
Okay, so y's right there, right?
Uh-huh.
I know y is a negative 1, so I put it right back there.
Okay.
So I take a negative 2 times a negative 1 plus 6. So I can find x. Does that make sense to you?
Yeah.
Okay. So now I have a negative 2 times a negative 1, which is 2 plus 6, and I get 8. Now, be careful. This line, these two lines, right here, these two lines intersect in a point. And that point is what? 8, a negative 1. It's really easy to put the negative 1 in the x spot because you solve for it first. We got to be careful there. We don't want to do all this work and then get the answer wrong because I flipped the numbers. Jackson, do you get that? All right.
Do we have to graph these points?
No.
No?
That's the great thing, is you don't have to graph them, but it's a bad thing because you can't see your answer. Do you see what I'm saying? It's like a double-edged sword. You don't have to graph, but you can't see what you're doing. Right? Okay. Let's take a look at this one. Y equals 2x minus 4 and a negative 6x plus 3y equals a negative 12. Okay.
2x minus 4.
Is number 1 true or number 2?
Number 1.
Number 1 is true. One of the variables is solved for. Okay, so we're going to just circle it now and put it in for y, correct? Because y equals that. So I have a negative 6x plus 3 times 2x. I'm going to change it to a negative 4 if you don't care. Equals a negative 12. Does everybody see what I did?
Mm-hmm.
We're good, Ashley?
Yep.
All right. So now I have a negative 6x. Why are you smiling, Ashley?
I'm not.
Okay, I thought maybe you knew what was going to happen.
Mm-hmm.
All right. Equals this. Now what happens when I add these two together? They what? They cancel.
So this one's no solution?
Oh, now hold on. Hold on, Braxton. Look at that. Look at my answer. A negative 12 equals a negative 12. Is that a true statement? This is infinite solutions. Now, I'm going to ask you, Braxton, since you brought it up, how do I know if it's no solution?
They're both zero.
No, they won't equal each other. Good job, Ashley. They won't equal each other. So this will be like a negative 12, and this will be like 7. So if they equal each other, Braxton, and the x's go away, it's infinite solutions. If they don't equal each other, right, then it's no solution. You got it? Okay. Now, is anybody wondering why we don't use this method on everything? Oh, yes, ma'am.
Okay, what if there's like y equals on both of them?
Oh,
Makes sense?
yes. That is a great question. Is there any like that? Yeah, number 11 in your book. That is a great question. Wow, Tyra. Okay, here's number 11 in your book, and this is a great question. These are really hard to come up with, so I'm glad there was one like this. Tyra says, now they're both solved for y, aren't they? So I'm going to circle one of them. Doesn't matter which one, Tyra. and I'm going to put it in for y on the second one, right? So what happens is, Tyra, instead of getting everything on one side, they're on opposite sides. But I still have only one variable, don't I?
Oh, so you just said it.
So I just set them equal because I put it in for this y. Do you see where I put it in for that y? And then I change both these to negative, and then I'm going to subtract 2x from both sides. Remember doing this? It's a two-stepper. So I have x plus a negative 2 equals a negative 5. Does that make sense, Tyra? Now I still only have one variable, right? So, but Tyra, now I'm just going to subtract a negative 2 from both sides, and I get x equals negative 3. Now remember, I got to put it back up here, don't I? Right? So I take a negative 3 and I go y equals, remember I circled it for a reason, 3 times a negative 3 plus a negative 2. So I get a negative 3, nope, negative 9, sorry. Negative 9 plus a negative 2, I get a negative 11. So this order pair, I ran out of room down here, so I'm going to put it on the side here, is a negative 3 and negative 11. So these two lines intersect at a negative 3 and negative 11. What do you think of those apples? Okay? That works out.
Way less work.
Yeah. I think it's easier than graphing. However, sometimes we forget what we're doing, right? Because we're solving. Tyra, notice how Tyra is looking at the problems in the assignment. Why are you doing that, Tyra? Yes, you do know, and is a great. Tyra's looking to see, okay, what am I going to be confronted with so that I could ask him now? Is that right, Tyra? Yeah. All right. And hopefully I've answered most of the questions. Okay? So, Jackson, your assignment, and I'm going to have Ashley write this up on the board. Your assignment is page 351, numbers 8 through 20. It is due tomorrow. You only have about 12 problems, okay? So, but they can be a little bit long. So, all right? Okay. And if you have questions, you can always look back at the video.